So very good evening to all of you who are there beyond the screen in this live session. This is the third and the last live session for this particular course on lighter than air systems. So today we are going to talk about some power plant related issues and tail sizing of airships. After that, we will proceed to some discussion regarding the final examination. We will show you some sample questions after discussing, and after that we will discuss some queries which have been raised by the students, and then the standard discussion forum and queries. So as I said, we will start today with electrical propulsion for airships. You know that airships are being touted as environmental friendly modes of transportation, primarily because of the very low fuel consumption that they require as compared to other modes of air transportation. However, if you want to go into application of non-fossil propulsion systems, or at least reducing the amount of fuel used, then one way to go forward is to use what is called as hybrid propulsion. And to be specific, we can use hybrid electric propulsion, which is basically mingling of two or more different systems to provide the propulsive power. The HEP, or the hybrid electric propulsion, will consist of a combination of the internal combustion engine or ICE with the electrical motor or the EM. So it will be basically ICEM in a way, ICE plus EM. Now, we need to understand the benefits and why should we go for this particular scheme, HEP. There are many reasons, there are many motivations. The first one is that it gives you improved fuel efficiency. Here you can go for optimized engine loading with the support available from the electrical propulsive device as and when needed, and also depending on the amount needed. So in the critical missions of the flight, where the thrust requirements are very high, such as during takeoff, climbing, or a high-speed flight where the propulsion system of the conventional nature is not enough, you could augment it using electrical propulsion. That is in the case of a hybrid system. Such a system also leads to lower emissions because the electrical motors, they don't emit anything while they are running, although they use batteries for their operation. And batteries are not really very environmental friendly because the process to create batteries involves a lot of exploitation of the resources of the earth. But once it is made, the consumption of a battery does not entail any environmental damage. So if it is a hybrid propulsion system and some part of it, it could be major, it could be minor. If that is electrical propulsion, then you will lead to that much reduction in the emissions because electrical motors are not proactively emitting anything. Then we also lead to lower noise levels when we use a hybrid electric propulsion, because again, the electrical motors, not only do they don't create any emissions, they also don't create a lot of noise. Those of you who have seen electrical vehicles, scooters or cars on the roads, sometimes when you are walking on the road, you will find that electrical scooter or a vehicle will go very near and you won't even hear it. You won't even notice. Unlike the IC engines, which we are used to hearing. So you will have a lower noise level if you have a hybrid electrical propulsion. It also gives you higher operational flexibility because you can have combinations. You can have only the IC engine operation, you may have electrical engine only operation, or you may have a combination of the two in any proportion that you deem fit. Then it also gives you much higher efficiency when operating under low speed flight, because electrical motors are efficient not only at one particular speed range but over a wide speed range. So toward in a larger speed range, you are able to acquire or you are able to operate with better efficiency. So the efficiency in low speed flight is very bad for conventional uh, engines. The use of hybrid electric propulsion also allows you to recover energy. Okay. But remember, only the electrical part is recoverable. You must have heard about several cars which charge the battery when there is a deceleration or when there is braking. So, you can recover the energy, which is not possible with the IC engine. And finally, you get lower maintenance costs because the moving parts in electrical systems are also much lower in number. So when you have less number of moving parts, you have lesser maintenance challenges. So these are the 7 key reasons why hybrid propulsion is being considered as a good alternative to conventional ICE. So there could be several layouts of hybrid electric propulsion. So you could have a system where you have a 2-level hybrid, where you have one line which is dedicatedly giving a conventional fuel supply system which goes to the ICE, and there could be a parallel line where electrical battery can start charging and give to the electrical motor. Together, this power is channelized to a single propeller. So what is the problem here? The problem here is we don't know how to decide the breakup. How much power comes from the ICE and how much power comes from the EM is not immediately known. And there could be different ways of arriving at what is the correct combination of the two powers. So there are 2 steps. There are 2 solutions, and the first of them is called as the degree of hybridization, which will be abbreviated with the symbol phi in what follows. Phi, by definition, is the ratio of the electrical energy stored in the batteries, called as EBAT, to the total energy stored, which is the EBAT plus E fuel. So imagine there are 2 sources of energy, the fuel and the battery. How much of that total is from the battery? That decides the degree of hybridization phi, DOH. When phi equal to 0, it's fully conventional. When phi equal to 1, it's fully electric. The other parameter that has to be kept in mind is the power split ratio, or PSR. The power split ratio basically is the ratio of how much power is coming, how much shaft power is coming from the motor to how much it is coming from the total sources. So shaft power from motor upon total shaft power, that would be called as the PSR, or the power split ratio. So phi and S are the 2 parameters which have to be kept in mind. So if you look at now the layout, okay, you will notice that when you want to decide how much should be each, you can decide based on the value of parameters xi and S. So 1 minus xi into E total is coming from the fuel supply. 1 minus S upon of the P total is coming from there to the propulsive device, and vice versa. Phi into E total is coming from the electrical side, and S into P total is going to come from the electrical side to the power consumption. Okay, so now there are 2 questions that arise. One question is, how do we integrate these 2 parameters, phi and S, into the design? And also, how do you determine them? How do you get their values? Now, to answer these questions, there are various equations which we have to look at. Okay. First, let us start with the conventional Breguet range equation, which all of us are familiar from our basic classes of aircraft performance. The Breguet range equation, called as BRE for conventional aircraft, in the SFC form, for a device which uses the propeller, is the eta P by Cp propulsive efficiency into the aerodynamic efficiency CL by CD times the natural log of the weight ratio, that is the initial mass over the final mass with the mission fuel consumed. This is the standard Breguet-Range equation. And now we have to see how this equation can be modified for a full electric and also for a hybrid system. So for electrical aircraft in 2012, there is a paper by Hepperle in which the modified Breguet-Range equation is given for an all-electric aircraft. Now here there is no hybridization, it is fully electric aircraft. So this particular equation states that the range is equal to the total efficiency eta tot into the battery energy density or HBAT, which is in joules per kg, times the aerodynamic efficiency and times the ratio of battery weight to total weight. And the value of G is given to ensure that the units used are consistent, because some units are in joules per kg, some units are, so it should be in the value of R should come in meters. And that's why we need to use this value of G. So eta total into HBAT into aerodynamic efficiency into the weight ratio of battery and total by G is the range for the fully electric aircraft. Now we need to look at how to hybridize them, how to mix them together in this mixer, because the left hand side represents the condition when xi equal to 0. On the right hand side, we have a condition when xi equal to 1. And any combination of hybrid will be in between 0 and 1. So to do that, there are a few equations to be considered. The first of them is given by Batra in 2023. Batra has given the modified Breguet-Range equation for hybrid electric aircraft. In the energy balance form, it is as shown on the screen, where you can see now a large number of parameters have come in. So take some time to go through these parameters, and then you realize that now we have three efficiencies: eta 1 for the IC engine, eta 2 for the battery motor system, and eta 3 for the similarly. Okay, so then there is also the energy density of the battery pack and the fuel. Okay, so this is then the equation for hybrid electrical aircraft. Now, if you look at what to do for the airship, because we are looking at airships, we are looking at a course on LTA systems where we need to convert the equations applicable to aircraft into the one's equation applicable to airship. So using the approach by Grant Carrickner in the book Carrickner and Nicolai, which is the volume 2 of the famous series of book on aircraft design, the value of R or the range can be obtained using the expression that you see on your screens. Okay. So here also you can see that there are various efficiencies which have to be considered. Now, this definitely is very, very confusing and very complicated, because there are several terms here. So therefore, there is a need to simplify this approach. So you can simplify the previous equation as just eta 3 times aerodynamic efficiency into 1 upon 1 minus S EF by G and log of the weight ratio. Now the weight ratio WHO itself can be expanded, because that is the initial static heaviness, and WH1 will be the final static heaviness. So using these two parameters, you can actually simplify that equation. So this definitely looks much, much simpler and cleaner compared to the equation that you see on the screen now. But essentially it's the same thing. You can see it's a log of weight ratio into a big term minus B upon a small term minus B. And those terms can be obtained directly from the values as shown. Now, determining the value of phi and S is the second issue that we had faced. So if you look at the Breguet-Range equation of an airship with hybrid electric propulsion, depending on the function of the value of psi, you can, as I said, take psi equal to 0 for conventional and psi equal to 1 for all electric. You can get the value of S as in terms of eta 2 and eta 1 with 1 minus psi and psi. So if we look at now the design considerations of the hybrid electric propulsion as far as airships are concerned, we have to keep in mind that the battery weight or MBAT, total MBAT, is a function or indication of the pack energy density. This is not just the cell, but the pack of cells. And packages includes things like battery management system, thermal management system, wiring and the casing. It could be more than 1/3 of the total mass. And therefore, the pack energy density is generally only 2/3 of the cell level value, which is quoted by the manufacturer. Right? Then battery charge cannot be drained to 0% state of charge. So if you do that, it can be disastrous because the cells may go into deep discharge. And once it goes into deep discharge, it loses the ability to be charged again. So it's gone, it's consumed. Because of this, you have to ensure that you don't discharge the battery up to very low levels. 20% is generally what is to the safe lower limit or desirable lower limit. 10% would be the absolute lower limit. And this puts when you start losing the charge, you lose the life cycle. Okay, so we don't want to charge the battery to full 100% of the state of charge, because if you do that, you are going to lose the battery life. And in the last few percentages, the time taken will be also much more. The time taken from 10% to 20% is far less compared to 80 to 90%. So this is a very inefficient way of charging, right? Now, the other electrical components that are there on the airship, they may have a higher power density than the conventional, but they require careful design selection. Okay. And also what architecture you follow is also very crucial. We have only seen one particular architecture, but there could be hybrid parallel, hybrid series, and various other kinds of architectures which can be used. So the current preference is to use the turboelectric, series turboelectric. So you run the gas at at optimum temperature or optimum conditions, plus you have a optimum or better power control using the DEP. The long-term goal is to implement the series parallel architecture, which has got the widest operational flexibility. Now, if you couple unequal powertrains, there could be serious problem. It may lead to disbalances or movements in the system which are difficult to overcome. And then if you want to overcome such high movements, you have to have very strong gears designed beyond that particular range. So it can lead to many complications. On top of that, there is a requirement of thrust vectoring and swiveling of the propellers. That becomes a bigger challenge to incorporate in these kind of systems. So this is an area of research and a lot of work is going on in this area. Now we move on to the next part of the series, that is on the fin sizing. Now you must be wondering why an envelope requires fins and what all can be done to optimize the shape and the size of the fins, and of course the number and the configuration. So tail fins are important because they are the ones which are available for providing the flight stability, for providing the control, and for also ensuring that the trim drag is at a minimum value. So by trim drag, we mean the drag caused due to deflection of the control surfaces with intentionally overcoming the imbalance. So the use of control surfaces in an airship allows you for motion in all 6 degrees of freedom, the pitch, the yaw, and for roll stability. Actually, for roll control, we don't see any advantage of anybody building an airship that flies along a particular roll axis, because here the mechanism of the generation is not the same as the aircraft. So normally we see that we use these motors for pitch control and for yaw control. And we can also use these surfaces for the LTA systems or LTA vehicles, primarily because the size of the vehicle itself is quite large to give you very good moment arm. Now, why does tail sizing occupy so much of significance? Because the provision of tail actually contributes approximately 20% of zero lift drag coefficient, the remaining going mainly to the fuselage and to the wing. So if you look at the structural impact, around 10 to 14% of the total weight of the aircraft, empty weight of the aircraft, will be because of the tails. So the effects of tail sizing are found in many domains, including but not limited to stability, control, and aerodynamic performance. Tail placement is influenced by center of gravity, and it also influences the location of center of gravity because of its reasonably large size. Okay, so now there are two-phase methodology also available. One is you do initial sizing using historical data. So you don't actually bring in the tails, you bring the effect of the tail in terms of the weight to be carried. And then you just incorporate that loss into your calculations. Or you might be a little bit more proactive. You might try to do a parametric estimation. If you have not only one, but many organizations pitching for the same project or for the same activity, and that will require detailed aerodynamic stability and control analysis for you to be able to predict anything and everything related to that particular system. Initial sizing is dependent heavily on past data and company information. Proprietary information, that is the one that drives initial sizing. The parametric refinement, on the other hand, doesn't bother to know about the company policies. It strikes separately using detailed aerodynamic stability and control analysis. Okay, so you can see this is like designing a airship as a picture on an aircraft, transmitting that information through the tower, and then someone takes it up for fabrication, exactly matching with the original design. Now, what is meant by initial sizing? We have to size the vertical tail. The vertical tail gives weathercock stability because the vertical tail generally is a structure earlier which used to be hinged to the aircraft, and the pilot, co-pilot, or the faculty member who is sitting there, only these people were authorized to lift this particular, they only were authorized to take care of the deflections, etc. So the weathercock stability is something that automatically provides stability and control, right? So you need to have good yaw and roll damping, and that comes from the area and the location from the center of gravity. So if you look at a family of airships or series of airships which have been already made, successfully flown, you can get the data like what is the vertical tail area, what is the vertical tail moment arm, what is the airship forebody length, and what is the envelope volume of the airship. And using that, you can create some correlations, such as the one shown here. CVT is equal to SVT by SVT into LVT divided by length into volume power 2 by 3. So volume power 2 by 3 will be, units will be meter square, L will be meter square, will be meter, so it will be meter cube, and SVT will be meter square, L will be meter, so it becomes a dimensionless parameter called as the vertical tail volume coefficient. Note that typically the length of the center of gravity of the tail with the center of gravity of the airship is between around 36 to 43%. If you have an airship with much larger value of these parameters, then your correlations, the correlations that we are giving, they will not match. So the CVT value will be given as a desirable or an appropriate value, and you will know the value of volume, you will know the value of the length, LB. You also will know the value of SVT, you will know the values. LVT will be the location. and then SVT will be the parameter that you can calculate to get the surface area. Similarly, you can also do the horizontal tail sizing. Horizontal tail is required for pitch stability, which is a nose up and nose down motion, right? So here the criteria is to ensure that the static stability in the pitch mode is in a stable domain. Right? You have the neutral point behind center of gravity that ensures that you are not going to diverge. So there is a similar formula where we have CHT instead of CVT, and we replace the value of LHT and SHT. We replace the values of the parameter. CHT will be available from literature, and knowing the other parameters, you can get the value of SHP or the area. Now, if we look at the literature, you will realize that there are some attenuation factors. These factors are experimental parameters which will help us bring in some realism into the calculations given by the previous formulae. So there could be a full attenuation factor, which is the average effectiveness accounting for interferences and flow direction losses. These are micro parameters. You can have projection attenuation factor, or you can have a correction projected factor. Now, refine tails using geometry. So that is one of the parameters. So initially what you do is, initially you can assume the value of the tail area based on the tail stability coefficients, SVT, SLT. But in the refined sizing, you can use geometry and aerodynamic relationship to improve this. You can look at how tail shape affects the performance, and you can scale the tail area to meet requirements of stability. Now, long ago, we had published a paper in this area where we looked at the data of some 47 airships which were flying at that time. Painstakingly, by contacting the manufacturers, by looking at standard documents, and by looking at some airship companies, we got that data. And on the same lines as what we do for aircraft, we have created an equation for airships also. Plus, the book by Karikner, which I recommend most people to read, also has details on how to do the size. Now we move on to some hints and some ideas about the examination that you are going to appear. Or some of you who have registered or signed up for the examination, you would be keen to know what the examination will be like. Now, we cannot disclose the paper to you, obviously, but we can only tell you about what kind of questions will come. So the course TAs have sat together and compiled some sample questions. But first, some information. The exam is not very far away. It's just on the weekend. Okay. And it's a 3-hour examination without any pen or paper. It is going to be completely computer-based. And you are also allowed to use only the computer on the screen on the screen. You are not allowed to bring your own calculators. So there is a calculator on the screen which has to be used by the students to give the examination. So therefore, keep some margin for getting familiar with that particular tool. But if you have given JEE Main or JEE Advanced examination for entry into the college, you would be aware of this because you have already gone through that whole rigmarole. But even if you have never given any examination like GATE or the IIT entrance, you can notice that it's an objective type question. Okay. Now, there will be 4 kinds of questions. There will be some MCQs. MCQs are the easiest. Okay. They are the easiest because an MCQ is by definition a question in which only one of the choices is correct. So if there are 4 choices, only one will be correct. If there are 5, only one will be correct. So sometimes students are able to eliminate some of the choices and arrive at the, the choice that seems most plausible as an MCQ. Therefore, we have introduced one more variety of questions called as MSQ, multiple select questions. Now, broadly speaking, in MSQs, more than one answer may be correct. All answers may be correct, 3 out of 4 may be correct, 2 out of 4 may be correct, but also please remember this, in an MSQ, there could also be only one answer correct. So you have to be very confident and sure when you answer MSQs, because no guesswork will be possible. In MSQs, unless you choose all the correct choices and do not choose any wrong choice, you will not get a mark. I'll repeat this. Unless you select all the correct choices, which could be only one choice, unless you click or accept all correct choices and no wrong choice, you will get the mark. NAT stands for the numerical aptitude test. In numerical aptitude, there will be questions, numericals, and then there are some questions which are fill in the blanks, where an important keyword related to LTS systems is to be guessed by you by looking at the sentence. So there are going to be 3 sections in the question paper. Section 1 is the easiest section, which actually is a gift from our side, because these 20 questions are a direct copy from the assignments. Okay, that will come later. So these are based on the recall of the material. Okay, so these are questions, 20 questions, each of 1 mark. These are based on what you recall from the from the material that you read, from the videos. Okay. Section 2 will be an assignment recall. So as you know, there are 12 assignments, 1 every week. If you have done all the assignments carefully, and if you have cross-checked the answers of the assignment questions with your own answers to identify discrepancies, if you are not able to figure out where you are wrong, then there is a problem. But these are questions which are taken directly from the assignment which you have given. So if you do the assignments well, and if you follow up with the model solutions and correct your answers if needed, you will be able to easily get 40 marks. And remember, 40 marks are actually the passing marks in the question paper. Correct? So 40, or is it 50? 40. So 40 marks you can easily get pure. So passing in this course is not difficult at all. The difference between a good student and the average student is only what you know more than section 2. And then you have section 3, which is the really challenging part. In section 3, there are 20 questions which are of 2 marks each. Some of them are MSQ. They also could be MCQ. They could be. And there will be also questions which are from all over the syllabus. And this could be completely new questions. So friends, we'll try to give you a flavor of this particular quiz or examination by showing you some sample questions. And by the way, the full examination is going to have 60 marks, and out of 100 marks, 60 questions out of 100 marks. So you need to do the 60 questions in a 3-hour period. Here is an example of a question for section 1, which is a recall from the content given in the course notes. Plow gas was used in Zeppelins because of what reason? Okay, so if there is anybody on board, can you please answer the question? Can you unmute yourself and tell us what is the answer of this question? This is an MCQ. That means only one answer is correct. So what could be the reason for using Blau gas in Zeppelin? Okay, so the answer to the question is B, which is that Blau gas had a density very similar to air, and hence when the Blau gas is consumed, there will not be too much effect on the buoyancy. This is a question which has come from week number 10. Similarly, the next question is, which of the following are load-bearing candidates for the fabric? Polyester, nylon 66, Kevlar, and PVC. This is also an MSQ, so more than one answer may be correct. Yes, the answers are polyester, nylon 66, and Kevlar. PVC is not at all load-bearing. This is a question from week number 7's content. None of these questions have already been asked in the assignment, and therefore you will not also see them necessarily in the question paper. So be careful. I'm just giving you a flavor of the examination. Next question is a fill in the blanks question. Gross lift Lg is proportional to PS into kV upon TA. The constant K is approximately what? This is a numerical question of 1 mark, right? The answer to that is the value of the parameter. K is 0.03416. Another question which is fill in the blank type of 1 mark, just to indicate to you what type of physical features of various metals should be known to you. So the warp and the weft are the two directions. So you should know that it is weft. Then from section 2, another example. This is an MCQ. Hydrogen hybrid airships were lifted generated using wings. They are called as dynastats. They are called as aerostats, or airships with wings are dynastats. Okay, this is from the assignment number 4. Now, suppose somebody has clicked aerostats also here and H sample aircraft also here. It is not public knowledge. It may be happening. You may be aware of it, but you have to answer based on publicly available information. Remember, it's a 2 marks question. So you have to also spending more time to this. One more example in the formulation of added mass, the apparent mass matrix for an axisymmetrical correction of airship is all these options are available, and you need to choose the correct option, which is the Bravo, synthetic and configuration dependent. So with this, we want to wish you all the best for your examination. We hope that you have learned a lot by doing this course. And we also wish that some of you will definitely be shortlisted for internships and you will come and join us. The floor will be open now for any questions or any queries that you may have. As always, I say that we need feedback from the performers. So please, you should give the feedback as soon as possible. But it will be a good idea now for us to spend some time listening to you and to check what kind of queries you may have. So we will stop sharing our screen. And we will open the floor. So since it's a session which is being recorded on the channel, maybe people have not joined, so it's okay. They can have a look at it later on. So with that, I come to the end of the session. If you have any questions, you can ask us right on the YouTube live as well as on the chat window. If there are no questions, then I just want to wish you all the best for your examinations, and I want to stop this session. Try to take it by me.